Okay, we're doing SAT test number 9, section 3. It's part 2. This is 11 through 20. And the first problem is number 11 here. And it looks like a number 11 we have x over x minus 3 is equal to 2x over 2. Well, this 2 and that 2 will cancel out. And so what we can do is we can do a little cross product. This becomes 1 here. 1 times x is x. If we multiply across like that. And then x times the other diagonal this way. X times x minus 3. And so we want to see what are the possible values of x that satisfy this equation. It looks like we might have a quadratic equation, so there could be 2 answers here. So if we multiply x times x, that's x squared, and x times the minus 3, that's minus 3x, and that was equal to x on the left hand side. And so what we want to do is get all the x's on one side, so subtract x here and subtract x there so that we can set it equal to 0. And so we now have that x squared minus 3x minus x is minus 4x. So then the next question is, can we factor this out? Yeah, you could factor out an x. If you factor an x, you're left with x minus 4. And that's equal to 0. And so it looks to me like x equals to 0. And x minus 4 is equal to 0. So x equals to 4. And x equals to 0. So there's 2 answers in this problem. And so the answer should be B. B is the correct answer. And there's probably other ways of doing it, but that's probably the easiest way for most students to do that problem. Okay, problem number 12. It says 1 over 2x plus 1 plus 5. Which of the following is equivalent to the expression above for x is greater than 0? So we have a denominator here of 2x plus 1. And notice that the answers, they're all going to have the same denominator, 2x plus 1. So that means that in this problem, we should write the second term here with the same denominator. So what I'm going to do is I'm going to multiply the numerator and denominator by 2x plus 1. So we're not changing the problem. We're just multiplying by the same thing, numerator and denominator. And when we do that, we distribute 5 times that and 5 times that. And you're going to have 10x plus 5. And over here you had a plus 1 already. So if you take those, and I'm not even bothered with the denominator because I already know the denominator is going to be the same. The numerator has to have a 10x plus 6. So the answer here should be D, 10x plus 6. Now there is a quick way of checking if you didn't want to do all of this. Maybe a student might say, well, what if we tried a number? What if we tried x equal to 0? If x equal to 0 here, this would be 0. 1 over 1 is 1 plus 5. You would get 6 when x equals to 0. Okay? Here, if x equals to 0, you get 5. Here, if x equals to 0, you get 6. And here, if x equals to 0, you get 5. And here, if x equals to 0, you get 6. Maybe 0 is not the best thing to try since it said x has to be greater than 0. So pick a number greater than 0. Let's say maybe, so it's either this answer here or this answer if you try numbers. Maybe you could try a number like x is 1/2 or x is 1. If x is 1, you're going to have 1 over 2 plus 1 plus the 5. So you're going to have 2 plus 1 is 3, so this would be 5 1/3. And all I'm doing is I'm plugging in x equals to 1. So in this one, if I plug in x equals to 1, I'm going to have 2 plus 6, that's 8. And here you're going to have 2 plus 1 is 3. So 8/3 is not 5 1/3 because that's actually 16 over 3. And then over here, if you plug in a 1, you're going to have 16 over 3, which is the correct answer. So for some students, they might like trying in numbers, but I think this is probably the easiest way of doing it, the way we did it first. Just leave a comment in the comment section. Let me know which is easier for you, trying numbers on some of these problems or just working them out the algebra way. Let me know what you think. Okay, so the next problem, number 13, we have a parabola, and the graph of the function is shown in the xy plane above. Which of the following defines f? So we're looking for the equation for that parabola, and in this case we have the vertex here, and that's 3 comma 1, so that means that h is 3 and k is 1. And so the answers are in vertex form, so you're going to have y is equal to a times x minus h squared plus k. So we already know h is 3, so we're going to have x minus 3 squared. And we already know that k is 1. So we have an equation here that says y, or f of x, same thing, is equal to a times x minus 3. So what we need to know is what is a in this problem so we could come up with the answer. Well, what we could do is just pick a point, any of these 2 points, 2, 5, or 4, 5. Let's say 2, 5. So when x is 2, y would be 5. And this way we could find out what a is. And this would be, when x is 2, 2 minus 3 squared plus 1. 2 minus 3 is negative 1, squared is 1. So you're going to have 1. That's just a plus 1 is 5. So that means that a should be 4. So if you look at your answers there, we look at answer B, a is 4, and we have the x plus 3 here. Actually, it was x minus 3. Yeah, so it's not this one. Notice that we have x minus 8, so it should be x minus 3. And then we have a is 4, and we have k there. So these look very similar, so you need to make sure that you get the right answer, because many times students are picking the wrong answer, but they look very similar. So the correct answer for number 13 should be A, and that is correct. Okay, problem number 14, we have system of inequalities above. In which of the following does the shaded region represent the solution set in the xy plane to the system of inequalities? Okay, the first one says that y is greater than or equal to x plus 2. Now I look at all of these, and the lines are all the same. So y is greater than or equal to x plus 2 is going to be this line right here, or this line right there, or this one right there, or this one right there. So the lines are drawn correctly, and maybe I'll use yellow for the second one, and the second one is going to be in yellow. 2x plus 3y less than or equal to 6 is going to be this one right here. It's going to be this one right here, and this one right here. And I'm highlighting these for you so that you can see that all they really need to know is what is the region. You don't have to worry about the lines. It's what is the proper region. Well, let's take a look at this. Y is greater than x. If y is greater than x, then this would be everything above that line. So we need a shade above the green line. So it would be everything on this side, and it looks like this one missed the boat completely. And again, we're looking for above the green line, so it would be everything here in this area. So this is a possibility there. And for this one, we're looking for above the green line, and this is a possibility there because there's some shaded there. And above the green line, this one is also missed about there. It's not above the green line. So now on the yellow one here, we're looking for y would be less than negative 2x plus 6. So less than or equal to would be everything below. So we're going to look at everything below the yellow line. So this one's already out, so we're not looking at that, and we're not looking at this one. So below the yellow line here would be this area. that would rule this one out, rule out B. And we're looking below the yellow line. Actually, below the yellow line, we want everything below the yellow line, which would include this region right here. So at this point in the classroom, I would ask, is it B or C? Well, it's going to be where they overlap. Below the yellow line would be this part right here, and we already ruled that above the green line was this part right here. So it has to be, for number 14, it has to be answer B. So you just have to be careful on the regions that are shaded, and you can go ahead and write on your test when you're taking the test doing it that way. And so the answer is definitely B. There's a way that you could check is you could pick a point in this region. And if we were to pick a point, let's say negative 1, 2, 3, negative 3, 0 falls in that region. So you could try this point and see if it satisfies both inequalities. So when y is 0, that would have to be greater than or equal to a negative 3 plus 2, because x is negative 3, and that checks out in the first one. And then on the second one, we have 2x, so it would be 2 times a negative 3, which is a negative 6, plus 3 times y, which is 0. That has to be less than or equal to 6, and negative 6 is less than 6, so that checks out. So that's one way that you can check. Now you only want to check if you have enough time to go back and do this. Otherwise, keep moving because it is a time test. So that was for number 14. Okay, problem number 15, we have a radical equation. What is a set of all solutions to this equation? Well, one thing that we could do is that we could square both sides to get rid of the radical. And when we do that, we're going to have x plus 2 on the left-hand side is equal to a negative x squared. Negative x times negative x would be positive x squared. So we have a quadratic equation, and we want to write this in standard form. So I'm going to have minus x minus 2 so that we could set it equal to 0. Those cancel. So then the next thing we could do is we could factor this out and see if we can factor this. So x squared would be x times x, and then factors of 2 would be 1 and 2. We have a negative 2 and a minus there, so let's try minus and plus and see if that works. Minus 2x and a plus x gives us that minus x there in the middle, so it looks like it checks out. So we now have x minus 2 is equal to 0, and x plus 1 is equal to 0, and x equals to 2, and x equals to negative 1. And if you look at your answer choices, the answer is A. And at this point in the classroom, I might say, raise your hand if you got answer A. And 90% of the hands will go up, and it is the wrong answer. A is wrong. Why is it wrong? Well, whenever you have radical equations like this, you need to plug it back in and check. So, to see if it works. If I plug a 2 back in here, 2 plus 2 is 4, so I have the square root of 4, which is 2, and that's equal to negative 2. Well, no, it doesn't. So this does not work. This is actually called an extraneous solution. This is an extraneous solution, and this is extraneous work. And it's not needed. Because if you're going to plug in these answers, the answers are given to you right here, here, and here. So it's either negative 1 and 2, negative 1, or just 2, or just negative 1. So when we tried the 2 and it didn't work, that ruled this answer out, that ruled that answer out, and all you do is try negative 1, and so you're going to have negative 1 plus 2, square root of that is equal to negative 1, and this is the square root of 1, which is 1, and a negative 1 is 1, and 1 equals 1, so it checks out, so that means our answer was B. Now, if you like this little tip strategy of just plugging in the answers for this problem number 15 with radical equations, leave a comment in the comment section. Let me know what you think. Okay, problem number 16. What is the volume in cubic centimeters of a right rectangular prism that has a length of 4 centimeters, a width of 9 centimeters, and a height of 10 centimeters? So in this problem, if we're looking for volume, a right rectangular prism looks like a box, and all you need to do is find the length times the width times the height. So we're going to have 4 times 9 times 10. 4 times 9 is 36, and 36 times 10 is 360, and that's your answer right there. Problem number 17 says, if x satisfies the equation above, what is the value of 2x plus 1? Okay, so we're looking for 2x plus 1, and we have 4x plus 2. So most students will probably do what? They'll subtract 2 on both sides, and that'll cancel out. So you're going to have 4x is equal to 4 minus 2 is 2, and then you divide by 4, and the answer is 2/4, which is 1/2, or 0.5, or just 0.5. Now, what I noticed was that in this problem, when you had 4x plus 2 equals 4, here's an alternate way. If you're looking for 2x plus 1, if you recognize that this is twice that, then all you need to do is divide everything by 2. Divide by 2 on both sides, and when you do that, you get 2x plus 1 on the left-hand side is equal to 2. We're looking for 2x plus 1, right? So the answer here is 2. Now, if a student went over here and did it this way, and they got x equals to 1/2, guess what happened? They forgot to plug it back in and they missed it. So this is one of the tricks for the SAT. So I'm going to say this is a little bit tricky. It looks easy, and it looks pretty simple. Students are used to solving for x. They're not used to solving for 2x plus 1. So for problem number 17, the answer was 2. Okay, problem number 18. We have a figure here. The figure above shows a complete graph of the function f in xy plane. The function g, which is not shown, is defined by g of x is f of x plus 6. So g of x would be just 6 more than f of x. What is the maximum value of the function g of x? Well, first find the maximum value of f of x. What is the maximum value of f of x? Okay, the maximum value would be here, or here, or here. And regardless, the maximum value is going to be a horizontal line going through those 3 points, and it looks like that would be 2. What this plus 6 does is that it moves everything up 6 units. It's a vertical translation. So if the maximum here was 2, and g of x is going to be 6 more than that, all you need to do is add 6 more to the 2 that you already had, and so the maximum value of g is 8, and that was the answer for number 18. Problem number 19, we have a triangle PQR has a right angle at Q, and the sine of R is given as 4/5. What is the value of the tangent of angle P? So in this problem, it would be very helpful to just draw a little right triangle like that, and it says the right angle is at Q. So we're going to say that this is angle Q, and this could be P, Q, and R. Okay, and we're going to know that the sine of R is given as 4/5. So the sine is the opposite over the hypotenuse. And so opposite of angle R, here's angle R. So opposite angle R, this is going to be 4, and the hypotenuse is going to be 5. And if you recognize this triangle, it's a 3, 4, 5 right triangle. If you don't, you're going to have to use the Pythagorean theorem, and then a squared plus b squared equals c squared to get this 3. Okay. Now, they're asking what is the value of the tangent of P? So we're looking for the tangent of P. And so the tangent is defined as the ratio of the opposite side to the adjacent. Okay, so the opposite side would be 3, opposite of angle P, and the adjacent would be 4. So then the tangent of P is going to be 3 over 4, or you could write 0.75 or just 0.75. Either one of those would be correct. And if you forgot your right triangle trigonometry relationships, you have sine, so, ka, and toa. And so you need to know these real well for the SAT. The sine is opposite over hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent, which we just did, is opposite over adjacent. So in this problem, you actually wind up using 2 of those. So that means on the next test, you'll probably see the cosine. Okay, problem number 20. This is the last one for this section. The graph of the linear function f is shown in the xy plane above, and the graph of the linear function g, which is not shown, is perpendicular to the graph of, and passes through the point 1, 3. So let's see, where's the point 1, 3? It would be right here, and it's going to go perpendicular, so it might be somewhere in here like that. You might have a line going something like this maybe. What is the value of g of O? In other words, in the function when x is 0, they're actually asking for the y-intercept. And it looks like it's somewhere between 2 and 3. And we're not sure what that is. It could be 2.4, 2.5, 2.6, somewhere in there. So we need to calculate this. And so the first thing that we need to do is we need to find the slope of the given line. And the slope of the given line here, we're going to call m, is going to be the rise and the run. So it goes down 2 units, and it goes across 1. So the slope is -2, 2 over 1, or just -2. So we have the slope of that line, and it says, so we're going to look for the y-intercept. So we need y is equal to mx plus b, and we know that the slope of the given line is -2. So what is the slope for the perpendicular line, which is going to be the green one? Upside down t is perpendicular. So it would be the negative reciprocal of -2. So it would be positive 1/2. So that's what we're going to use here. And we already know that we have a point 1, 3 on that line, 1, 3. So that means that what we're going to do is say when x is 1, y is 3, and the slope is 1/2, and we can find what b is, the y-intercept. So 3 is equal to 1/2, or 0.5, plus b. If you subtract 1/2 or subtract 0.5 on both sides, then b is the y-intercept. That's going to be 2.5. This point right here is going to be 2.5. Is that the answer? Well, yes, because they want g of 0. In other words, when x is 0. So I'm going to just write the problem down. I'm going to say y is equal to 1/2, which is a slope, x, and then plus b, which is 2.5. So this is the equation of the green line that I drew up here. This is this green line right here. And so when x is 0, this would be 0, 0 plus 2.5. Then y of 0 is going to be 2.5, which is our y-intercept. So 2.5 was the answer for this problem. That was for problem number 20. Now, if you enjoyed watching this video, go ahead and subscribe if you haven't already. Thank you for watching. Thank you for subscribing. And if you like these types of problems and you want me to do more, just hit the like button. Give me a thumbs up. Thank you very much. Appreciate you watching. Take care now.